So when we say running water, we know that the water is always moved from one sphere to another, and we have actually 4 types of spheres. We have the hydrosphere, we have the atmosphere, we have the geosphere, and we have the biosphere. And we cover the 4 types of spheres in the introductory lecture in the geology, which means that the first lecture we talk about the hydrosphere, atmosphere, geosphere, and the biosphere. And the water moves from one sphere to another. And this unending circulation of moving of water, we call it hydrologic cycle. Okay, so this unending circulation of water is called hydrologic cycle. And we are a special planet. The Earth is a very special planet because we are the only planet in the solar system with global oceans and with hydrologic cycle, and that make life very easy for us. Actually, without the water and the hydrologic cycles, it's difficult for us to live in the Earth. So the Earth is the only planet in the solar system that has global ocean and hydrologic cycle. And we know that water is almost everywhere on the Earth. We can find water in oceans, we can find water in glaciers, rivers, lakes, air, soil, and living tissues. And if we are going to see the distribution of the total global water, we will find that the largest portion of the global water we can find it in the oceans. The oceans represent about 96.5%. The largest majority lies in the oceans. Also, we have about 1% in the saline lakes and saline groundwater. We need to know that we have saline lakes and freshwater lakes, and we have saline groundwater and we have fresh groundwater. Here, mainly you are talking about the saline lakes and the groundwater. So both of them represent 1%, while the freshwater represent only 2.5%. So you can imagine, it's mean that the smallest portion, the fresh water represent only a small portion of the total global water. So if we are going to talk mainly about the fresh water, we say that the fresh water represent 2.5%, and if we are talking about this 2.5%, we will have surface water, and we have fresh groundwater, and we have glaciers and ice sheets. Okay, so if we are talking about the 2.5%, we have 1.3% surface water, and we have 30% groundwater, and we have 68.6 glaciers and ice sheets, which means the glaciers, most of the fresh water are locked in the glaciers and ice sheets, and it's very difficult to obtain the fresh water from the glaciers. So we need also talk about the accessible water for us, which is mainly the surface water and other fresh water. So if we are talking only about this portion here, we have 0.22% atmosphere, fresh water in the atmosphere. We have 0.22% biological water. We have 0.46% in the rivers. We have fresh water in the swamps. We have fresh water in soil moistures. We have fresh water in lakes. And finally, we have fresh water in snow and ice, which about 73%. Again, here we can see that the fresh water, mostly we can find it in frozen state. Okay, so only 2.5% of the fresh water represented in the global water, and again we will find like 1.3% of that fresh water is only surface water, and we can find that rivers represent only 0.46% of the fresh water. Okay, any questions so far? Let's move on. We need to talk about the hydrologic cycle, the movement itself, how the water is going to move from one sphere to another. So in order to do that, we need to understand the evaporation process. When we say evaporation, it means that the process by which the water is going to change from liquid to vapor. Okay, so water is going to change from liquid into vapor. So water evaporates from the oceans and also evaporates from plants and also evaporates from soil and move through the atmosphere. When it's moved through the atmosphere, it condenses and it's form clouds. You have the clouds, and if we have the clouds, then water can leave the clouds and convert into liquid state again. We call this precipitation. So water leaves the atmosphere via precipitation. So precipitation is the process by which the water is going to change from vapor to liquid once again. Okay, so the precipitation, when the water change to liquid, the precipitation could cause, or it could soaks into the ground, which means that the water, it will try to infiltrate inside the ground. We call this process infiltration. Or it can runs over the surface. We call this runoff. Or it could evaporate if the weather is very hot, or it could be stored as a part of snowfield or glacier, and that take place when the weather is very cold. So if you have precipitation, and if the weather is cold, that means the water is going to stored as a part of snowfield or glaciers. Okay, so precipitation, it could be as infiltration, it could be as runoff, it could be as evaporation again, or it could be stored in snowfield or glaciers. Also, we have something called transpiration. When we say transpiration, it means that the water absorbed by plants and later transferred to the atmosphere. So the water, the plants will try to absorb water, and later on that water, it might be evaporate to the atmosphere. As evaporation and transpiration both move water from the surface to atmosphere, they are often considered a combined process called evapotranspiration. So whether the evaporation, which is a process in which the water changes from liquid to vapor, whether it's from oceans or whether it's from planet, we call this process evapotranspiration. Okay, and we need to remember that the hydrologic cycle is balanced. Its balance means that even though the water moves from one form to another, the total amount on Earth remain the same. So the total amount is the same, even though it could be found in different form. Okay, so again, we have the evaporation process, we have the precipitation process, we have the transpiration process. Okay, in order to understand the interactions of the hydrologic cycle, we need to look into that picture here. So here, as you can see, we have the evaporations. It could be from oceans here, which means that the water change from being liquid to vapor, or it could be from plants, or it could be from soils. We say that we call this process evaporation and transpiration, and we give it a name which is evapotranspiration.
Doctor?
Okay, then the vapor will condense and it's going to form clouds, and then in certain conditions precipitation will take place, which means that the vapors will try to change again to be a liquid. Okay, and the precipitations, it may precipitate into the ocean or precipitate in the ground here. In that case, we'll call it runoff, or it could infiltrate inside the groundwater or inside the ground, and we call this infiltration. Okay. Also, if the weather is very hot, it will evaporate again. And if the weather is cold, it will be locked in the glaciers or snow field. Okay, so this picture here summarizes the hydrologic cycles. We have evaporation, we have precipitation, we have transpiration, we have infiltration, we could have runoff, and etc. We need to know the difference between runoff and infiltration. Why should I have runoff and why should I have infiltration? And in which case, and it depends on what? So that depends on first the intensity and duration of the rainfall, and also depends on the amount of water already in the soil, and also depends on the type of soil, depends on the slope of the land, and depends on the nature of vegetative cover. Okay, so for example, if you are talking about the type of soil, why do you think the type of soil is going to affect the runoff or the infiltration process? Anyone can guess why the type of soil is going to affect the runoff or infiltration?
Yes, doctor. Maybe it can be rocky, and maybe some.
Yes. For example, if you have a rocky soil or you have rocky soil, what it's likely to take place? Runoff or infiltration?
It will not absorb the water.
Which means
like,
that it will have
yes,
runoff. So type of the soil plays an important role in determining whether you have runoff or infiltration. Okay. What about the amount of water already in the soil? For example, if the soil is saturated, which one is likely to take place? Runoff or infiltration?
Infiltration.
If the water is saturated?
مركز. Runoff.
If the water is saturated, that means it has the full capacity of the water, which means that the soil cannot take more water because the pores inside the soil is completely filled with water. So in that case, the runoff is likely more to occur. Okay. So when the surface is impermeable, which means that like the rocky soil, impermeable, that means the water cannot get inside the surface. Okay, so if the surface is impermeable or it's saturated, runoff is dominant, which means that the runoff is more likely to take place if you have impermeable surface or saturated surface. Okay, so runoff is high in urban areas due to buildings, roads, and parking lots. And it makes sense that in the urban areas where you can find the cities, runoff is going to take place because most of the surfaces are impermeable, and most of the surface is impermeable. You have buildings, you have roads, and you have parking lots. Okay, so runoff will start as sheet flow, like a sheets of flow. The runoff will start like that. I think most of you see the runoff in your streets, since most of you are living in urban areas, right? We are living in urban areas, so we are going to see runoff a lot, right? So for example, if you have rainfall inside the asphalt, you are going to see runoff, mainly because the surface is impermeable, right? So the runoff will start as sheet flow. Then sheet flow develop into a tiny channels called rills. This one is the rills. Okay, so small channels like this one. Okay, then the rills meet to form gullies. The gullies is like that. So first I have a runoff, then it will develop to have a tiny channels called rills. Okay, then the rills, it will meet to form gullies, and gullies join to form brooks, creeks, or streams. We call this brooks or creeks. And when we say stream, stream means that any water that flows in a channel, regardless of its size. So if you have a water flow in a channel, regardless of its size, we call this one stream. Okay, and when we say a river, that means it's a stream but carries a substantial amount of water, and it has many tributaries, and it has many branches which feed the river. Because mainly, if you have a river, that means you have branches which is provide the rivers with water. Okay, so the runoff will start as sheet flow, then rills will develop, and then will form to meet the gullies, and the gullies will join the streams or brooks or creeks. Okay, and finally, most of them will try to provide water for the rivers. Okay, so any question before we move on regarding the running water?
Clear, Doctor.
Okay, let's move on then. Then we have something called drainage basins. We have something called drainage basins. So if you have a stream, you have to have a place where the stream can absorb water from it, right? Because if you have streams, that means you have a source for that stream. You have an area through which the stream is going to be fed with water. Okay, so stream drains an area of land called drainage basin or watershed. So drains mean that I'm going to remove water from an area. In other words, if you have streams, the stream will remove or absorb water from an area of a land. We call this area of a land, we call it a drainage basin or watershed. Okay, so first I need you to look into this picture here. So if you have a water and you have a topography like this one here, then all the water will be in a form of runoff. The runoff, it will go to rills or galleries to feed the stream. So here I have a stream, but the stream will absorb the water from all of this area here. We call this one drainage basins. So drainage basin is the area through which the stream can absorb water. Okay, and here we have a line between that part and that part. If you magnify this part here, we call this divide. So divide is a line between two drainage basins. So this one is going to be a drainage basins, and this one here another drainage basins. So here I have a stream here, and also I have a stream there. This stream absorbs the water from that drainage basin, while that stream here absorb water from that drainage basins. So the divide here, drainage divide, is the line between two drainage basins. So a stream drains an area of a land called drainage basin or watershed. We have that imaginary line separating one basin from the another, and it's called divide. Like we just said, this one is a divide. This line here, this one is the divide. Of course, this one is imaginary line. Okay, it's divide the one drainage basin from another, and sometimes it's visible as a high ridge in a mountains region. So if you have a mountain region like this one, the line is going to be visible. You can see it. Okay, but if you have subdued topography, which means that the level is similar to each other, it's difficult to see the divide line. Okay, so continental divide, we have something called continental divide. split a continent into a different drainage basins. So the divide, it could divide a continent into a different drainage basin. To understand this, we can see the United States of America, which, like we say, that is just like a continent because it's very big and it has different type of climate. So if you can see in that picture here, we have the Mississippi River drainage basins. Okay, so the drainage divide, it could divide that continent into a different basin. So we have the Missouri river basins here. We have the upper Mississippi here. We have the Ohio river basins, and we can see here the divide. It could divide a continent into a different drainage basins, because the area here, it will try to provide the main river here with the water, while this area, it will try to supply the main river here with water. The same thing here, the same thing here, and so on. So the drainage divide, it has the ability to divide a continent into different drainage basin, into different watershed. Okay, so if we are talking about this drainage basins here, this one, if you are going to magnify this picture into that one, we have the Yellowstone Lake. This one, we have one branch here, one branch here, one branch here. So the purpose of all of the area here is to provide the main river with water. So this one is the drainage basins, small drainage basins. So you can divide a continent into many drainage basins. Okay, is that point clear for all of you? The drainage basin and the drainage divide, is it clear for you?
Yes, clear.
Yes, so let's move on if it's clear. Again, the rivers, we can find the river in systems. So rivers drain much of the land area. So if I have a river in some place, that means the river is going to absorb water from that land. Whenever I have a river, the river will absorb the water from all the surrounding area. Of course, we have exception. If you have polar region or extremely arid region, which means that you are not going to be able to absorb the water from the surrounded area. And also the variety of rivers that exist is a reflection of a different environment they are found in. So river is not only streams that absorb water from the surrounding area, but also is a reflection for the different environment exist around. Okay, and also if you have human intervention, or if you have climate differences, of course, this is going to affect the character of the river. So if, for example, if you are going to build a dam, so now building a dam is, you can consider it as human intervention. So if you build a dam in a river, which means that you are going to change the character of the river. Many things is going to change. So if you have human intervention, or if you have climate differences, it will be reflected in the surrounding river. And we can divide the river system into 3 zones. So we have the sediment production, which means that in that sediment production, the erosion will dominate. And you have sediment transportation, and we have sediment deposition. So we are going to divide the river system into 3 zones. The first one is the sediment production. We have the sediment transportation, and we have the sediment deposition. So here we have the headwaters. We call this zone of sediment or production or erosion, and we have zone of transportation, which is here, and we have zone of deposition. So let's start with the first one, the zone of sediment. So when we say sediment production, the zone where most sediment is derived, which means that we will try to get most of the sediment from that area, and it's going to be located in the headwater region. This one is, we call it the headwater region, the beginning of the river. And the sediment generated by three things. It could be from bedrock broken into smaller pieces. So we have a bedrock here. We have, of course, the physical weathering and the chemical weathering. So we can have sediments from the broken bedrocks, or from bank erosions from the sides of the streams here, or scoring of the channel bed, which means that the frictions between the lower part of the water with the bedrock. We are going to scouring the channel bed. So at that zone here, we could have bedrock broken into smaller pieces. We could have bank erosion. We could have scouring of the channel bed. Okay, so most of this process is going to take place in the zone of sediments. Okay, where we are going to produce sediments for that region. The other region, which is the sediment transport, sediments is transported into trunk streams. So in this region here, the sediments is going to be transported from that zone into zone of the deposition. And also, we need to know that the amount of sediment being eroded equal the amount of sediment being deposited. So the things you are going to get from here is going to be deposit here. Okay. So what we will get from that region, you are going to put it into that region. So the last region is the sediment deposition. When a river reach a large body of water, you have a large body of water, the energy decreases. The energy of the river is going to be decreases. And if the energy decreases, that means the river we're going to deposit sediments in that region. And you need to know one thing, typically only fine sediments are going to deposit into the oceans. Only the fine sediments is going to be deposited in the region, because the coarser sediments is going to be deposited in that zone. Okay, so I think the time is over. I'm going